to another stream. You're probably wondering why I'm streaming on the odd Monday, because last night, what the heck is this? Yesterday, I'm gonna be distracted by this song. Yesterday I played this game called The Farmer. It was replaced. It's a game about automation and programming. And I got tons of concurrent viewers, like 7 viewers. I think they were all AFK because I AFK an hour and they all say. Nope, I'm just gonna do the same thing again. Play Minecraft and do programming. But today we're gonna do the maze. I was gonna watch that. So we're gonna do the maze today. Looks like this. I mean, he'll get there eventually. Okay, who will get there eventually? Yeah. So I need to get this. So I need to program the robot to that's right. So I need to get the robot to the treasure chest. And there's a couple of ways to do this. One, which is what I did now, which is to make it truly random. Which we'll get there eventually, but it's not the way to do that. The best way is to use an algorithm called A*, and I don't know how to do that on the top of my head, so I'm just going to do the next best thing. Next best thing. There's a lot of ways to do it. Now, let me try maybe a search algorithm. So like maybe something that tracks where it's been. Or maybe... yeah, maybe something that's tracked where it's been. So at least it would be hard if it's like it gets to a dead end and it can't go anywhere. But isn't that simulated thing as fast as previous conditions? Not really. That's just so if we test where it's been and it can't go anywhere, and ignore do depth first search. You know what I mean? It takes note of where it's been. Goes one direction. Okay. So yeah, depth first search should work. So essentially what I'm thinking is we can go move until you reach a point, crossover those two things. Take note of that. Take note of the position of that. Go that way. If it's a dead end, go back. And then go. And then we'll do that forever. And there's a thing called recursion in coding. So let's do search. So if we call search here, the function inside the function, that's essentially exactly the same as the oh, can't do too many traffic cones. Wait, oh. Okay, I guess it doesn't like how many, oh. Okay, it looks like it doesn't like too many, but that's quite a lot. That's probably reasonable. We can work with that. Okay. So say okay, so we want to keep track of where we've been. So maybe let's use a dictionary. Or list of lists. Dictionary, list of lists. This dictionary we could have the actual coordinates. This list we have the coordinates. Maybe it's the dictionary. Oops. Let's try dictionary. So enter. So we hold in the dictionary. We hold the places we've been. So at the start, we're going to do append. Let's do get y x. Let's just fix that. So this will append dictionary. Hang on, that doesn't really work. And do that. This is kind of funny. Okay, what? I searched. Let's just quickly check that. Okay, it was like that. Let's see how it's done. I'm not sure why it says append. Okay. Let's do that. Actually, yeah, we're setting it to 1. Let's get rid of. How much do we have? 30k. Okay, it's not really. I'm using much. Okay, 001. Okay. Oh, what if you spawn it in the middle? That would be interesting. Gives it more chance to find it? Or, yeah, basically the same. So now we know we've been. So you want to look for up, down. And then we're going to check which direction we can do it. So get lists, which direction we can go, and then for each direction, for search. Is that right? For each direction, call search. Like if we have listed up and down, up or north, this. Okay. Get a list of which direction you can go. A bunch of statements or for each direction. Yes. North, south, east, west. Which direction? If can move that direction, then add it to the list of possible. Equals. Oops. So this will have a list of possible moves. Now that you have the list of possible moves, and check each direction. So how we do that situation. So you should just commit to one direction. So move this direction until it can't move. So keep moving north until it can't move. Oh, we can't do this, can we? Because that doesn't look worth it. Oh, it can. We have to pass the delivery every single time. No, it's fine, it's fine. We can return it. So we're gonna have to return the dictionary. So go up. So locate, say we put it here, move one of the directions. Move that direction. Switch. So if we go through this, we add the current position to the dictionary. We get the list of possible moves, since we're like north, east. Possible moves, and then remove north. This, and we actually go back to this and we record the position, get the direction, and then keep going, and move one direction, so we keep going. So every single block of the maze search function will call. And we're gonna print the dictionary the whole time. Let's see how we go. Nope. What? Oh, oops. Okay, stop. Okay, so it's not checking where it's been before. So if north. So this is the dictionary we have here. He knows he can go south or east. So this is like where it's been. I've been here. So, each direction. You need to have something here. Maybe here. It's like check if it's been there before. Or maybe just here. Maybe here. Check if it's been there before. I do realize this. If okay. So we need to get the direction and then find the coordinate of that direction. So it might be a separate function. So like function using direction. Yep. Yep. So return get direction towards north. Get the new direction. So if we do something like get new direction, if new direction in dictionary, then skip. So we want to return true or false. Yeah, we want to return the coordinate. Yeah, get the coordinate. So what we get x, get y, x. Yep. So return the current position, but with the north going up. I have to do this for each direction. Is there a way to do this better? Not really. I could do a dictionary. So we could have direction. What is up? Actually, what is north? By the way, can we see this? Okay, no, doesn't matter. We'll do this. If this was done in Minecraft language, I would just do a bunch of if statements. But since it's an actual coding language, it's dictionary. Oops. Yes. This is so we can do direction map. Return direction map. Class direction map. do. So we paste that, I paste that. So now this would get the coordinate. So if it's like north, 0 plus 0 plus 1. Southeast, if it's east, it will be plus 1 here in the exponential. So now we got the direction. So if that direction, if the new location we're going to is in the dictionary, skip it. Don't add it to the possible routes. Yep, this should work. It should just go like to a dead end, and then we'll see how that goes. What? Oh, because I should actually stick there. Oh. Because it's a tuple, you can't do that, can you? Wait. Show list. Right. Can I do one? Sorry. Can you do this in tuples? I don't know actually. We'll find out. Yep, works. Cool. It's works exactly how I expected. It moves all the way to a dead end. Say that again. Cool. So now what happens when we're in the dead end? So if there's no possible moves left, we go backwards. So I think, like, yeah, we need to undo the move basically. So we go forward. Like if we're here, we're gonna go forward. Find out there's no moves, we're gonna go backwards. So instead of here, yeah, we have to move the opposite direction. So you want to get the opposite direction. Turn, opposite direction. Yeah. And yep. So in theory, when we run out of moves, it's like at the very end, there's no possible moves, which means that we skip this entirely. We move this way. We move the opposite direction. And then the same thing again happens. So this should go like forward and then backwards. Oh, yep, exactly what happened. But why did it stop? It didn't continue. So if we look at this, 001. Oh, it started here, went forward, went back. But the problem is, why did it stop here? quick break because we did quite a bit now. Remember to move. Leave it on the other one. See if this up and running. Or I figure it out. Oh, it just wiped the output. Okay, so what happened is so got to the end. Oh, because you know what happened when it's like when it moves forward, it will go back that direction. But because we start at 0, it's like we didn't have any move before. So it's still working. How did you base the no? Like you only know which direction to go. Unless you can actually simulate. So that'll be interesting. You have to move the drone. The problem with A star is like you have to know the whole map. Like realistically, a drone doesn't know the whole base. Which direction you can go in every feature. Kind of has to search for it. So depth first search is actually probably the best way. Yeah, that's good. Oh, it could use some more way to choose directions though. Yeah, let's see what's going on. So we have singing, we have one language. Need a bit more copies. So let's pick this. Go choose. Great wood. Oh, okay, expand. Should we do that now? What should we do? So I'll stop there. So the only, so let's see, expand. Oh. Okay, 16 by 16, so we need 16 of these. So, 5. Maybe some more wheat. 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 15. Where are my more carrots? We got heaps of wood, so. And we'll increase the pumpkin patch. Actually, do we have carpets? Yeah. Need carpets. Maybe a one less. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Get rid of one bush. Just get rid of one of these. Bushes. Actually, seaweed, yeah. Actually, seaweed here. Because this is slightly more here. Let's put the weed here. Okay, so if we do just change the pumpkin size as well. Oh, we got plenty of wood, I assume. And that should be good. Oops. Let's see sunflowers over there, then something like. Whoa, this is quite big. Still another bush. I don't really get the sunflower. I guess if you make it more efficient, then you don't need so much space to put the sunflowers. Yo, freshy pod, what is that? How's the editing going? Look at that. Didn't have to change it much. Just have to change what I wanted the rows to be. I do want to continue trying the maze out. Where farmer? Let's go. So let's get to the maze. So which is okay, it stops. Yeah. So let's simulate this. If we go here, if we start here. We go up or east. We go up. We go up. East, east. So from here. Oh, I kind of want to see it again. So in here, it knows you can go up or north or east. Then each bin goes up. You're like, uh-oh, there's no more spaces available, so we have to go back. Move opposite direction. There's no possible move, so move back. not really. Oh, okay. Did it not get the direction? Oh, maybe. We do here. Well, it missed it. Oh my goodness, what's going on? Okay, so now I think it's completely working. How did it go through everything and not? Oh, when harvested. Okay, yeah. Oh, we did it. Yes. Okay. Now we just need to find out how to harvest it. That's position measure. So this is where the treasure is. Treasure. So move. The first thing we do is if we're on the treasure. X. This. Pause one. This is gonna look weird. Treasure. Collect. Harvest. Oh, it moves as well. No, what? No, that loops in the maze make it more difficult because it means that you can get the same location again. So let's try the one treasure. It does seem to slow down. Searching. Yo, let's go. Why is this still going? Yo, let's go. I did it. That first search without looking up anything. Yo, that's awesome. Just need to do, and it's actually exactly. Awesome. Why is it? Exit on treasure. What's something other than no. Search text. Oh wait, it missed it. I don't know if this is overloading the memory. Let's try backtracking. And no, it missed it. Oh, there we go. Oh my goodness, what's it doing now? Yeah, that works. It's just very memory intensive. Why does it? Yeah, it does need the dictionary of everything. Right. Maybe instead of in, I guess it's the same thing. Like, we're checking if it's in the dictionary, but we're not actually looking it up. Is it faster to look up or check if it's in? Okay. Check. Oh, it's cool. At the same time. So what I'm thinking is this is actually storing the entire like path of it, but we don't really need it if we go back. Thinking where I don't think we need to. Is that trash again? I don't see any. What's that? How do we break out of this? Return Oh, we're not actually checking this. That should end it. If result equals none. Yo, it's getting there. Let's go. Let's go. That's so cool. Oh, wrong one. It just gets the maze. It does the maze. It it finds. It's so far away. Oh. Miss it. Nope. Got it. Let's go. It's really slow though. That's the problem. So let's see. When we add it to the dictionary, can we like pop it? If it was a list, then So instead of going backwards, also remove it from the list. Let's remove it from the list. That's how you do it. This is not good for my technical interview skills. I have to check. Oh. To remove a key. So should like remove it from the memory. It's been there before. So it should be a bit faster. Oh no, it's exactly the same. It's just maybe just less memory. Let's go. So what can we do with the leaderboard? Oh, leaderboard, you have to do both of them fast. So where do we go? More drones? Let's get more drones. Let's see what happens. That's kind of interesting. That gets into like parallel processing, which is maybe a whole box. I know it's box. So let's do another one. I want to see where I can optimize this. It's kind of slow. I mean, memory intensive. What if I don't print it? Dictionary. So we got 2000. I like the drone. Mega farm. This incredibly powerful unlock gives you access to multiple drones. As you need to use 2 summon one drone, additional drones must be first spawned and then spawned as powers per drone. So each drone runs its own separate program. New drones can be spawned with function. So the drone will do the function. Drones do not collide, these maximum. Maybe just use that so much. Okay, let's say we have our main function here. Let's say we want to have a second drone that does like this leap here. Let's make this into a harvest main leap. So after it's tilled, so I should move this main function into the functions area. So after we've tilled the land, all drones can spawn other drones. Okay, interesting. So, say we want to. After we've tilled it, we want to spawn the drone. Have it run main. and then we'll do a couple flips to like wait a bit. And see what happens. So it's gonna till it. Then it's gonna spawn a drone to harvest everything. And it's gonna do a bunch of flips, and then it's gonna harvest stuff as well. Huh? Oh. Actually, it's not good. How do you spawn a drone with an argument? It is parallax, I think. What are we doing? My direction. It's just gonna be north. So just yeah. So it's gonna be tree counter. Tree counter is also very sensitive. What is this? What's this too? Stuff. See if we go. See how we go. So it should spawn the drone, do a bunch of flips, and then continue harvesting. No, what? Oh. Let's go. Two drones running behind each other so they can harvest the plant at the same time. Or harvest the plant. Essentially doubling our speed. That's the power of processing. Power's decreasing, I think. Oh, no, that's right. Ooh. Maybe we need a lot more drills to get him out. I'm thinking. I'm gonna do it at J. Let's try it. So for the maze, I was thinking, since we have another drone, we can use it to spawn it, have it search one section. Have it like discover one section. So let's use. I'm sure what's here. We need to use the. Drones, number of drones. So if next drones number of drones. Then we do the thing. Why do such a thing? Small drone. And do search. How do you search? Does that work? Let's have a look. No. That doesn't make any sense. Okay, let's just get back to this thing. Foot tests. One thing I'm not sure on is how to give the drone data. Yeah, maybe there's a way to do it with that data. Let's see. So does this actually do something? Checking possible progress. I feel like I can't. Honestly. Oops. So we're watching this. This is actually cool. What? This. Oh, is it here? Okay. Both being good. Yeah. For an extra challenge, you can also use the maze by using the same amount of items. So luckily, so this is saying like I can use the web substance on the treasure and it'll relocate the treasure. But every time I do that, it will remove walls, making it harder to. There'll be loops, but my code already handles loops really well because it tracks the previous location. Right? Is it? Oh, only one way to find out. So instead of harvesting it, but I want to implement the double drone thing. That'll be cool. Anyway, let's try this. Use word substance. So item. Word. What is it? Items. To say there's a 50% chance of items. Chance of harvested, 50% chance of harvested. So like it's a quick thing just to have a bit of randomness. It's really slow. So use the word substance. Now they have it. I think happened when I did that. We'll search with nothing. Reset. Is it there? Okay. It's not confirmed. Oh. What if we did a little search function? Just check if the treasure's nearby, you know what I mean? Treasure, check the treasure. It's theoretically, let's see the thing. Oops. So if you're like here, we can check this one, this row here, this tile here. It's nearby. We just go there. If it's 2 blocks away, I don't think we can do that. No, we can't really do that actually. Only if you can move that direction, and if it's there. Short optimization. Don't think it's worth it though. Could be. So if we go possible moves. So let's say we have a list of possible moves. Just check if the treasure's there. Oops. Oops. If it's this, if it's treasure. If current position. If the current position equals the treasure. Return the direction. Otherwise return. So I should optimize it like a tiny bit. I don't think we're going to do much. Small optimization, so that's alright. Not fixing the huge memory issue, which looks like we're forgetting. Okay, let's see if we can change this to guarantee we're gonna do it. And added weird stuff. Let's see what happens. There should be a 50% chance to add the weird stuff. I did it. No, it didn't work. It's right there. This thing didn't work. Check nearby for each direction. Get the current. Check if the position. Oh, this is returning those. We want to edit those. So maybe instead of this. No, just return Joe. And check nearby should return. So we're gonna make that. Okay, small optimization. Oh. For each action, we call it one argument. Nice. Oh. This is pretty lucky not getting the weird stuff. Oh, he added weird stuff. Okay. Oh my gosh. I can press this and I get. I'm so confused. Let's increase the chance of adding this stuff. Maybe I'm not actually using it. Use item. Items don't read assumptions. Don't know if it's working. Two, 5, 6, 1, 8, 7, 8, 30. 1, 7, 8. Extra strategy can also use in this space. Oh, same amount. Oh. Let's do 20%. So when it uses the red substance, it will reset and then basically the recursive function again, which is very very like memory intensive. It's going to be a lot of recursion. So maybe I can go away. Oh. What? So it did work, but it looks like it just got stuck. Oh, because I need to measure. This is funny. You should say yeah. Trying to say I added weird stuff and then it keeps going. Seven, 6, 8. Okay. Hopefully I don't run out of recursion memory. Because it is going quite deep. Oh, still going. It's up to 1.79. So the question is this faster than just running it a bunch of times? Because it's using the same amount of weird substance. I did it. Buy one full maze and move it to a random. It's things not worth it. if he invests the same amount to do the weird substance. Like we 16 to spawn it. I was just wondering this one I'm thinking. We 16 to spawn it. We also use 16 to double it. So we're using the same amount of gold. It's only worth it if the extra information is short. Okay, yeah, so it's faster only if it's... Yeah, over time it will be faster. If you use the shortcuts, it's to your advantage. So I think mine doesn't do that. Let's go. We got 7k gold. So since it's not worth it, let's just do the normal one. Is search. Repeat. And we'll go to over here. So this should constantly do the maze. Oh. Wait, what if he had multiple drones? Then adding weird stuff would make it way faster. Like let's do this for now. Just this. Now it's just automatically getting gold for me. Search. Like, how do you give it donuts? What if you don't? What if you make it get notes? So So in the code, so where is directions coming from? Directions and instructions blank. We could just have, I can't really do. We can have a function beforehand that says like start search, and it has to set. This just has no dictionary, and then search, and then we will do this start search. So what this means is we can spawn the drone here. So for move direction. So if we have two, like say, let's say we have multiple directions. Let's say we have multiple directions. So if possible moves is, if the length of possible moves is greater than 2 and greater than 1, and maximum number of drones is less than the number of drones we have. These take ticks. Maybe I shouldn't have this then. I guess this is alright. Not really. It's a bit slow. Let's go to the journey by. Oh, this one's good. If so if there's two directions, so say there's two directions here, you can spawn a drone to explore one section, and then it will just derp around as well after this. Yep. Instead of search, we do search. And then there should be like two. Oh. There should be like two drones that just are running around trying to look for the treasure. What? Oh, wait. What? What do you mean? Two is not an element of text is a bit small. 02 is not an element of set. So equals search. What do you mean? It's pointing to something different. Is that an element of the set? Oh. Let's do this. It confirms that it's related to the new guy on the block. Let's see that. So we're waiting for the new spawn to go. Keep doing it. Try again. Oh no. Okay, now see we're here. There's two possible moves, up and north and east. Spawn the drone. Okay. There's spawn the drone. Well, now we spawn the drone. Oh, because there's two. What? I don't know, man. Let's just run another one. Oops. Okay. Let's just run another one. Let's see. I'll ponder on that. New drone default. Let's get damage hay. Oh, she lowered so far. It's like it's using twice as much. Exactly. Cactus. I'm not really using cactus for anything. Maze. Increases the gold. Okay, maybe we do the cactus. Or maybe let's increase the water. Let's increase our water usage. Where's our water? Okay. Oops. Let's increase our water level to 50. Then, let's see, our spawn drones. Let's go for each. Get drone count. Max drones. Spawn drone. Do a flip. Wait, is max drones including the self? Nice one. Spawn a drone, do a bunch of flips. Spawn a drone, do a bunch of flips, and then run the function. Whoops. Sports on, sports on. We can go. The distance between them is a bit close still. Like this guy is not even. Catching. Oh, now they're clustering together, which is not good. Yep. That is the problem. So, increase the gap between them. And then, oops. And we'll look for a long-term solution. All drones are equal. That's how you use global variables. Grab a global variable. Hey. I want to see two drones. So I think there's two here. They do catch up on each other. Now there's three in this guy. Three together. Oh, now they're all clustered. And we're just burning through fuel. So I think it's pretty inefficient because it uses the same amount of fuel. What about after it's done? It just does a few flips. Let's see. For each in range, random multiplied by 3. And do a flip. Is that how that works? Yep, that's a random number of flips between 1 and 3. Drones went in. So I think the problem is because it doesn't harvest, it will go faster. And that's what causes them to catch up to each other. So maybe we could do a flip instead of don't really need the speed because we have 4 of them. Let's see what my 2 are. This was my idea before. Oh yeah. Do a flip if you can't harvest. Or maybe use fertilizer. So harvest, better harvest. So, oops. If it can't harvest, then there's a random chance that it's lighting. Also, it's with substance. Do a flip. Try to help. So use weird substance harvesting. The weird substance will instantly grow it. No. It's not weird substance, it's gonna be fertilizer. So the fertilizer will instantly grow it. And we can harvest it immediately. Otherwise you do it for we still have a yield. Yeah. Oh, it's a function, so we got functions. Why is it flipping? Oh, because we can't harvest it. Because there's nothing to harvest. I mean, there's nothing planted in the first place. Definitely way slower. They do naturally go apart, so we're on to something. Yeah, this one's way ahead now. Why is it collecting the wood? Yeah, it is. It's a funny way to divide the joints apart. I was thinking, what if they had their own sections, but it's gonna take a whole rewrite the code to handle multi-threading. We could split it up though. Like everyone takes a fourth. Since we would have rows. Except at the moment it's going like at each row. But you could split the responsibility of each, drain to 4 rows. So now you can take in a thing called murders. Maybe let's have a look at what this does. Zero, 1, 2. So that's all the drains are set. Cool. Problem is, how do we instruct it? Do we instruct it? Shall we say? This. So let's say my row is 0. Reduce spawn row main. Actually, let's see if I can this. Takes 1 minute. So there's really no way to do that. Okay, that's just how you do it. So we receive the number being 0, 1, or 2. So what if we do like 1, 2. So the first train, let's say we have the first train is going. Where is it? Calculate here, it makes sense. So we want to get to 1, 2, 1, 2. Multiply it by the road to be equal to n times maximum number of joins the size, both sides, both sides being 16 divided by number of joins, which is 4. So and then we multiply by join 1. So 4 times 1 is 4, and then go to that position on the X. Which has really loud for some reason. See how rows is like, it will be this, all the rows. But we only want a section. Wait, where we? We're referencing this little variable. Okay, interesting. So instead of rows, by rows. We'll get the rows. Rows equals this is this is going to be starting X position. Rows is going to be between starting position and then starting position plus this number, which is going to be our factor. So this will get the starting position of the drone, which is 4. And the end position, which is 8. Let's see if that works. Quick print. So it should print this row, this row, this row, this row, and false. After this, oh, can't tap out. Entities carrot, carrot, wheat. Oh yeah, this one. Carrot, 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 wheat. Yeah, so that worked. So why? So now we need to move to that position. Move up. confused by the main drone screen. It's not spawning a drone. Oh, right. Let's it's just this one. Not quite. Something's not quite right. Need to check. Selecting. This is testing if drone spawns and gets the argument. That is not what I pressed. Oops. The one argument of spawn drone was none. This is not a valid argument. Argument 1. Argument of spawn is not none. Okay, I am guessing. I can't do this. You know, whatever reason I thought was incorrect. Okay, let's say. What if we just spawn at the location? So let's say we spawn one here. That's 0, 0. So at 0. Spawn the guy does mean 1, 2, 3, 4. We do this. Remove both spaces. And then we spawn the drag, and then you guys How does the drone identify itself? What if it's like, oh, because I spawned in this location and this number? Which is really weird, but that works. We'll do that then. This should be like X. x. By it's gonna be the size of the thing, the size of the array. This one. Grab this. The get identifier is it gets the condition x. So like in our case it would be 0. We know we're number 1. If position equals 0, return 0. Now let's see if position equals 4, return 4. I feel like I'm missing something here. Maybe it is just this code. So we get the factor, which is the world size, divided by the variance. So 16 divided by 4. And then true. You get x position. It's like if it's 0 times 4, it's 0. If it's 1, like if we're like 4, don't need to times it by a factor. We already know what the x position is. So starting x plus the factor 4 by 1. Yeah. This one. So the first thing we're looking for is if this drone goes to the right, it goes east. Spawns a drone here, moves east, spawns a drone, moves east. Cool. Yep, exactly what I wanted. But first it's 2. But could we tilt them? I don't need to worry about tilling optimization because it's so what's up. That spawns the drones. They all do their own thing. Interesting. Let's see, why is it? Oh. I'm not sure why I'm doing this. Oh, it's just efficiency. Yeah. Let's go. There we go. They all have their dedicated rows. They're not dedicated. They're just going doing whatever. Yeah, this isn't expected. Yeah. My trees can grow in summer. Something's definitely wrong. So let's see. I'd say each. Okay, so we're assuming. So we're gonna get the original position, and we're gonna go back to the original position. Yep. Small inefficiency, but it's better than whatever this was. So return to original position. Original position. X, it's Y, show position, what if we just check. It's X. Which in this vector space. So the current position, let's say we're here. Current position 3 minus 0, so 1, 2, 3. Yep. Hopefully that should be set as well. Let's go. That's not working. Oh. This is a lot harder to debug. This is much more. It's up, down, up, down, plus. Okay, it's very hard to do, but because it's going east, because it planted a pumpkin. Do the smart planting system. Yeah, smart planting system. One new direction. This is only like south. And it calls next row. So we could have like a row counter. Progress. Every time it does a row, it adds on to the progress. If the progress is greater to the factor, actually let's see less. If it's less than the factor, do this. Otherwise, do this. So this should move the room back after it's done with the rows. What? Oh, I should do that. Okay, not quite sure what's going on here. Oh, we're resetting progress. That's not good. Let's push this guy. Plants, because left. So assuming it runs this code. But that means progress is 3, factor is 4, which is correct. 1. So let's say is up 1, 2, 3. That makes sense. So if it works well, this should just go back here. What? You got quiet. I mean, yeah, it is actually working. It's just a bit weird. I think the direction's a bit funny. So say it's going up, north, south, north, south. This doesn't change. Yeah. That should be good now. Looks like it ended. It's not. Where's it ended, by the way? There's no errors. Oh, it's for Tony. So we should get back and it's not following the instructions. Seems to be like randomly doing its thing. Maybe it's this. Let's double check this. I'm pretty narrows, but I don't see any. Looks like it was all fixed, and it's all working now. They've all got their own little dedicated rows, it's all dynamic. It's cool. It's really quite well. Tomorrow we'll do the dinosaur challenge. probably end it there. Yeah, it's a good time to stop. Thank you for those who are watching. Really appreciate it. If you are there, leave a comment so I know you're there, or chat, message, and maybe subscribe if you enjoy the content. I really don't know if anyone's watching. Yeah, it was quite a lot of fun. I love this game. Gotten pretty far pretty quickly. Just a little more challenges and I'll go for the or something. Yeah. Not sure what this left. So, thank you for watching everyone. Have a nice day. Goodbye.